Hello, I am Kaldan and today I am going to work with this circuit, and I was finding a circuit in Google so that I control my DC motor in a very efficient way. Then I got it. This is a very useful technique when it comes to battery source because it saves lot of power and gives us a longer runtime. So today basically I am going to analyze this circuit, how the circuit is worked, and at the end I am going to build one. So at first I am going to simulate this circuit in an online platform. So let's start the video.
Okay, this is the online platform where we can create the circuit and simulate it to get the result from it. And I have created this circuit accordingly. This is IC225 timer. This is the potentiometer, and these are the diode. This is the voltage source, and this is the in-channel MOSFET IRF540. And I have considered inductive load connected in series with the MOSFET and the voltage source. And this is the output terminal of this IC25 timer. This output terminal is directly connected to the gate terminal of this MOSFET. If the small current is applied to the gate terminal of this MOSFET, that result the turning on the MOSFET, and the current is flowed through the load to ground. And by changing this potentiometer knob, we can actually change the duty cycle of IC25 timer, and accordingly the IC25 timer is fed the pulse to the MOSFET. And by changing the knob position of this potentiometer, we can actually change the output average voltage. Okay, let's check the circuit graphically. Let's simulate it. Okay, and this is the voltage probe, and this it showing the instantaneous value. Let's analyze this graphically. Okay, this is the on time and this is the off time. The width of the on time is smaller than the width of the off time. That result, the output voltage is small because it's measure average. Okay, let's change the knob position to 50% and let's check the circuit behavior. Again, simulate it and let's observe graphically. Okay, this is the on time and this is the off time. At 50% of the duty cycle, you can see that the on time and off time width are equal. That means the output average voltage is half of the input voltage. And again, if I change the knob position to 80%, let's run the circuit again, and this is the graphical. Okay, you can say that on time is greater than the off time, and it is much greater than the off time. That means the higher output average voltage. That also result the faster spinning of the motor. Okay, this is the schematic, and according to that, the circuit is worked. And let's work on practical field in a prototype board and observe how the circuit is practically worked.
I have collected all the necessary components for my project, and then I have to solder in a prototype board. So I have attaching all the component in that board. Next process is soldering and create the circuitry. This is the final appearance of the circuit. and I have connected a LED so that it indicates the input, and I have connected wires for input and output also. And you can also try in your custom PCB so that your circuit looks good. At first we have to give the input, then the input will come and LED will also glow. And I have connected the multimeter of the output this circuit and also connected this DC gear motor. You can use any types of motor. I have used the gear motor. This speed variation is also less, so that you can see the multimeter and understand how the circuit is worked. Let's powering on the circuit and LED is glowing. And if I slowly move the potentiometer knob, then you see the voltage will rise and motor will start to spin. Yeah, this is voltage is rising and motor is spinning slowly. And again, if I try to rotate the opposite way of the potentiometer knob, then you can see that the voltage will start decrease and the motor speed will also decrease. And how that's and the circuit worked, you can see the circuit is working fine without any problem. If you use a higher capacity load, then you must connect a heatsink to the MOSFET, otherwise the MOSFET will burn. I have also burned two MOSFET while testing this circuit, and you must have to careful while testing this circuit. And hope you like to watch this video. Thank you.